is what quartz looks like, quartz in sand. The little green dots are silicon, and the little red dots are oxygen. And it's kind of a repeating unit. So the video we saw showed you heating up sand to high temperatures, and then actually that's fine, but it's the cool down that actually will get you what you want. And the cool down, notice you have the same like relative amounts of green silicons and red oxygens, but they're not ordered, they're not organized. They're in their solid state. This is crystalline, okay, and this is what we call an amorphous. Amorphous sounds like a sci-fi thing. Amorphous solid, it just means that there's not the order to it as it was as crystalline solid. So this is glass. This is quartz, as in sand. And there's different properties to that. Oh, maybe this will help. So I do have some videos, but not another video to show you this, kind of the making of glass. So you have to take silicon and heat it up really hot in order to get it to melt, and then you cool it down quickly to get that amorphous solid. In the wintertime around here, we add salts to our roads. Why do we do that? To melt the ice, exactly. It's something called, freezing point depressions. Freezing point depression, okay? And
my own may not do that because the animals all come like us and there's somebody in it anyways.
The animals would be attracted to the roads.
Yeah, they come like, I've had like bighorn sheep come in my truck and like this stuff up.
Oh my goodness.
Yeah.
Problematic. And so they don't do that?
You know, like near the Yellowstone, they don't.
Okay, but you can, do they use sand? Because I heard you can use sand.
They use sand.
Sand, okay. Very good. Well, both what sand and what salt does is the same thing. It basically interferes with the whole freezing process. That's why it lowers the freezing.
It also raises the boiling point.
And yeah, freezing point depression, boiling point elevation, exactly. For kind of similar reasons.
I like put salt in the water.
If you put salt in the water, it's going to boil at a higher temperature. Exactly. Boiling point elevation.
Did you get a new packet on the internet?
Parkour. Yes. I don't know if I brought one. Sorry. Fine. I thought it, yeah. I'm like, today I have been chasing my handouts, so I think I won this one. Cool. Here's your copy. So, very good. So with all of that in mind, this is kind of what they do. What they do is they put an additive to silicon to make it so that the glass melts at a lower temperature and freezes at a lower temperature, or a higher temperature. Melts and freezes both at a higher temperature. These particles, we kind of switch colors up on you. So this right here, you can kind of see the trio, the silicon is the gray. There's the gray, and then there's the white oxygens, okay, to kind of what was part of your quartz. But now you can kind of see some foreigners in there, okay? So it means that it will freeze at a higher temperature. It'll also strengthen it. Your textbook talks about this Gorilla Glass, and I have a picture of another standing on here. But anyway, Gorilla Glass is really strong. Oh, so it must be a word to fill in. Temperature. Temperature. All right. So. Oh, looks like there's another word, strength. So temperature there, strength there. but it's very similar to we add salt to the roads or sand to the roads to interfere with the freezing process. So I finish up with a problem. So if you have your calculator handy, or your phone, whatever you use for calculator. I want to talk about how dense something is. Now, density basically looks like this is something to fill in, right? The symbol for density in physical science or in chemistry is not the capital D, and a capital D and a dog. Instead of a D, what we do is we go to the Greek alphabet. We do this a lot for physical science, and we grab, this is the, looks like a P, and actually it's the symbol rho, which is a Greek letter. So rho, density, is equal to mass divided by volume. And it kind of makes sense. All you got to do is you isolate an object. We can take this object and calculate the density. All we'd have to do is go measure the mass on a scale, okay? And then we'd have to get the volume of this object. Now, math isn't my strongest suit. So there's a really cool way of getting volumes of objects like this. I call it the Crisco method. It used to be that Crisco came in tubs, and actually you need shortening, you'd have to say, I need a cup of shortening. Well, you had some options. You could take your 1 cup and kind of get all sloppy and stuff. Or you could take your 2 cup measuring cup, put 1 cup of cold water in it, and add shortening until it displaced the water up to 2 cups. So it's kind of a displacement. Again, 1 cup of water, dump in until the water gets to 2 cups, and that means your shortening is 1 cup. Start with 1 cup, now you're 2 cups. That volume displacement because of shortening. Anymore, they have the whole stick things. Okay? But we could have, and I wouldn't advise it, but we could have a beaker of water and make sure that the beaker will allow this to submerge, dump it in whatever elevation the water went up to. That would be the volume of this. I mention that because I think in your textbook sometimes they talk about that kind of displacement to get the volume. So all we got to do is take the mass divided by the volume, and voila, we have the density. In science, it's all about units. So good units of mass would be grams. Units of volume would be maybe milliliters. Okay. So typically units wouldn't have to be. Whatever units of your mass and volume divided, that's the unit you're going to carry along for your density. Don't make up units. So let's work one down here, and then I'm going to have you guys work one. So this word displaces, I hope you're kind of picturing what I just said, the whole kind of Crisco method, displaces. So a rock displaces 34.6 milliliters of water. So that must be the volume of the rock. And it gives us a mass, 2.5 grams, and we're supposed to knock out the density. We can do that. So density is equal to mass divided by volume. So I got 2.5 grams divided by 34.6 milliliters. Well, that's a good question. Since we're dividing, we're going to go with significant figures. So how many significant figures do you have in the top? 2. How many in the bottom? 3. So, yeah, so we have to go with the fewest, so 2. So what y'all get? Okay. So I think I got. So sometimes what I do, and I'm going to do it here, is I'm going to write down the calculator. I'm going to write down a bunch of digits, 0.072254, blah, 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 blah. What would the units be? Grams per milliliter. I'm liking it. Now, the whole thing about the 2 here and 3 here, so we're going to go with 2. So this first 0, it's a placeholder. So it does not count.
So it's 0.076.
Yep. So we're going to take 2 digits from left to right. We're going to truncate it there between the 2's. And since this is less than 5, we're going to go ahead and leave it. So 0.072 grams per milliliter. That's your answer. Okay. So now your turn. You can work together, or you can work by yourself, but I think it's relatively straightforward. It's a classic. We have a metal and we don't know its identity. Density is a good property to help you ID something like this. So we have the densities of these other metals, but we don't know what this metal is. So we have the mass and the volume of this metal. So kind of in a two-step process, we're going to come up with the density of the metal, and then we're going to compare that density with these metals to see which metal it might be. So go ahead and work that problem. Noisy, or is it synchronizing this morning? It is, okay. It's like it's ready to take off. So I think I see people saying, so what cover. Yep, very good. Okay, you guys are earning your participation points. Right, on to part 5. Dun, dun, dun. So, What's that?
This is the last part.
This is the last part, please. Part 5 is going to focus on, it's short, right? I have a few videos to show you, but sort of this idea, not sort of this idea, but it goes to, it's more complicated than recycling. It's on my list of things I need to do. How many people recycle in here? Not I'm glad. What's that? Never does see you. The whole recycling thing, I wish it was more convenient because right now it's hard to find a place in our house to keep things. Here in a minute, how many people recycle your phones?
I plan to, but I don't know.
Yeah. I think that's kind of where I am a little bit too. I'm not sure where we send it. I have a slide here to tell you from your textbook, like only 3% of people recycle their phones. So I don't know, but you can break them down and use the parts. So recycling obviously is important. Now there's this, in addition to recycling, I'm going to play this video for you. There's something called cradle to cradle, and it basically says you have something that is you use it, and instead of going to the grave, it goes to its grave, which actually is the cradle for something else. So cradle to cradle. Quite clever. Let's take a look at this video. Yeah, it's only 3%. It's already up here. Only 3% of people recycle. So, what else we got? This is a figure from your textbook, and it's going to show you for a year with regard to powering these devices. What are we talking about here? So, of course, the smaller the device, the less you have to spend a year to power them. Okay. We get a little larger laptop. This was interesting. Those digital photo frames. I got one from my mother-in-law. She never used it. But $10 a year to run that. Our new LED, well, new to us anyway, TVs, about $13 a year. And then your desktop PCs, about $30. And your Xbox 360, I know that's picking on, is that Nintendo? That's picking on them, $40 a year to power them. So of course that gets to our sustainability. Our larger TVs, plasma TVs, the old tiny tubes, cathode ray tube, CRT TVs. Okay. So, it's like the whole sustainability issue. Energy is a play. How we use it, how we create it, is it sustainable? So that's kind of what I think this is all about. I had another video, but I think I'm almost videoed out. Yes, ma'am.
Okay, so on the homework, it asked us a question about the rare earth metals, and it says that they're highlighted in blue. So this and this. But there was also TH was on there.
Thorium?
Yeah.
This guy?
So I got that question wrong because it's not highlighted in blue, so I didn't put it. Sorry.
Like challenge
On the homework. I didn't.
Did you?
I don't think it gave me it correct because I had to redo it anyway. But
When I played around with challenging it, so has anybody else challenged one before? They're supposed to tell you right away, give you feedback, they'll take it into consideration. The one I did that says, but it's been right for like the last
it
500
said there was
times.
like 4 challenges and 406 people have already answered the question. They probably just didn't hear, but I was mad because it wasn't highlighted blue.
Okay. And was this on the chapter 1 homework?
This is on the
LS, Learn Smart. Keep me posted because especially, I think for your Learn Smarts, I think you guys are going to be golden because I'm going to, only pick your top 5 out of the unit. And so that's chapters 1 and 2. So what'll happen is you take all of them. I just keep going through those Learn Smarts. And then what I'll do, I think at the end of unit 1 is go ahead and just, I'll basically delete them in the Canvas grade book if they're not maxed out. Do you know what I mean?
Yeah, because did it do one of them and it just has like a dash next to it? But I went back and I did the one for Monday because I missed that one. I went back and did it, but you can't get credit for it since it's like past due.
Okay.
So it gave me a 0 in there. So
Oh, I will do, yeah, I will be cleaning that up, because I'm pretty sure the dashes, the way the grade book works is the dashes won't count against you. And then, so I'm gonna like basically pare it down to your top 5. So, yeah. Okay. But what I was gonna say is definitely, and I know Autumn came with a question too, if it's a homework, and you're like, I don't think they did right, or heaven forbid you're taking a test and you think that Connect is screwing you over. Feel free to take a screenshot and run it past me. Okay, so, yeah, that's interesting. Yeah, so thorium, we'll have to I'll be curious if you should hear back from your challenge. I actually, because I wasn't, I couldn't figure out what are the rare earth metals. It's not a term that just rolls out of my, and so yeah, I just kind of took it at its word here, that these guys are the rare metals. Let's see how long this video is. I'm not going to show you, I have 2 more. Let's see how long this one is. Oh, 12 minutes. I don't have that much patience. Okay. I will, though, all kidding aside, I will go ahead and post it so on our Twitter feed in case you want to watch it. So I think this is almost the last slide or so. This is talking with regard to those elements. I assume the word rare means they aren't very abundant. Okay. Who has possession of them? Which country has? China has a lot.
How come like we just went to like nothing?
That is interesting. Well, let's see how long this one is.
Did you use them all?
Well, that's kind of what it's looking like, and then we kind of have it. So where are they? Because to me, this is production. So this isn't, the red is misleading. This actually is how much we're producing. So it's not that China, actually, if you look at the earth, it's not that they are finding them. Right, they're just actually producing them. They're cranking them out.
They might not actually have them all like in.
Right. Yeah, to me, we use the word natural resource. That means you have access to it, and that's not what this is saying. This is saying they're...
So we probably just exported all our work to China and that's
No, because it looks like we have a little uptick there. They're cranking out. Let me see how long this one is.